Hi, my name is Koen Geurts. I'm the Rosetta Lander Philae Technical Project Manager and I'm working at the German Aerospace Center DLR in Cologne. Today I will be explaining a little bit about Rosetta Lander Philae by using this 1:2 scale model here. What you're currently seeing is Philae in the on-comet configuration, but at the moment Philae is still attached to Rosetta in its cruise configuration. This means that the three landing gear legs that you're seeing are retracted and folded towards the main body. At the moment of landing, what will happen is several hours before landing, Philae will be separated from Rosetta. It means that Rosetta will push Philae off. Some point during the descent, the landing gear will be unfolded. This will allow for the legs to deploy and Philae is ready to land. What you're seeing here is one of the three Philae feet. Philae is supposed to touch down, of course, first with its feet. In particular, what you're seeing here is the Philae eye screw. All three feet have one of these eye screws that is integrated as part of the general foot, which will be penetrating the comet's surface, depending on surface hardness, of course, only driven by the impact of the touchdown. And what will happen is the eye screw will rotate and penetrate into the surface in order to fix Philae onto the surface. All three feet also have a scientific experiment integrated. In the soles, there are transmitters and receivers as functioning as a seismographic instrument. So the feet will be able to communicate from one to the other, transmitting sounds from one feet to the other, but also to listen to the comet and see if the comet, if there is any cracking or any other seismic activity. So as you can imagine, the comet gravitational attraction is not very high. So there's actually the risk that Philae bounces off the comet's surface in case there is a relatively hard impact. Of course, this is not something that we want, so we took some measures to avoid this. And one of them is what you see here, a harpoon. Philae actually has two harpoons mounted on the landing gear that will be shot into the comet upon the touchdown signal, and they will penetrate the comet, depending on its hardness, up to 2 meters. A cable is attached to the harpoon that will be rolled back and tighten the lander onto the comet's surface. In addition to the two harpoons, Philae has another device available to make sure that it will not bounce off the comet's surface. And this is a thruster which is mounted on top of Philae in order to thrust Philae onto the comet's surface. It will ignite at the touchdown and it will thrust for about 1 minute after touchdown. Philae cannot directly communicate with Earth, so for communication we heavily rely on the Rosetta orbiter to relay information from Philae back to Earth, but also commanding from Earth towards Philae. And for this purpose, Philae has a radio frequency transmitter and receiver mounted on the top, so that when Rosetta is passing and flying over Philae, a communication link can be established and the information can be exchanged. Relaying information from Rosetta back to Earth will take about half an hour of signal travel time, so everything which is happening on the comet will be known on Earth only about half an hour later. One of the Philae instruments is a drill, which you can see here. The drill has the capability to drill up into the comet's surface up to about 30 centimeters, and the tip of the drill has a sampling device that will be able to sample little comet parts. After sampling, the drill retracts back into the Philae main body with the sample inside, which is then deployed into small ovens which are mounted behind the drill and can then be rotated under different instruments so that the properties of the sample can be determined. So why are we taking comet surface samples? Well, simply because you want to learn and know what comets are made of. So the drill can of course take samples at different depths, but in addition, Philae has the capability to rotate its body for the full 360 degrees, which allows the drill to take samples at different locations. The instrument that you're seeing here is a comet thermometer, which at the moment is located inside the main body of Philae, and some point after landing, it will be deployed onto the comet's surface through this mechanical deployment system. What you're seeing here is the moment when it's just about to be hammered into the comet's surface. And this is done through this hammering device on the top of the thermometer. There's an electromagnetic device inside which will lift this weight up and down, and through this movement it will hammer the long thermometer, it's about 30 centimeters, completely into the comet. I'm sure that you, just like us, are very interested to see what the comet's surface actually looks like in detail. And for this reason, Philae has 7 panoramic cameras mounted around the body, which will give Philae the possibility to take a full 360-degree panorama image of the surface near to Philae, up to the horizon, perhaps even a little bit of space, and that is then used to look into detail what the comet looks like. In addition to the panoramic cameras, there's also a camera mounted on the bottom of Philae, which will take images whilst we are descending with increasing resolution while we're getting closer and closer to the comet's surface, which will give unprecedented images never seen before. Philae is also equipped with an additional set of antennas that are not used to communicate with Rosetta, but are part of an instrument which is located both on Philae but also on the Rosetta orbiter. And the two instruments, the two antennas, communicate with each other, not when Rosetta is inside, but when Rosetta is at the other side of the comet with respect to Philae, and the radio waves are traveling through the comet so that we can derive the properties of the inside of the comet. The mass of Philae is about 100 kilograms, and Philae is equipped with batteries in order to provide energy during the descent and just after landing, but in addition, solar panels are located all around the main body and on top of Philae in order to operate, hopefully for several months, on the comet's surface.